Hey guys, so today we're going to be talking about another chapter, a new chapter, chapter 3, graphing relationships. But before we do that, we're going to just go over the previous last part of the second chapter, which was about the inequalities and solving for x in those inequalities. So obviously inequalities are a little complicated because sometimes you can get the signs mixed up, but just remember that a greater than or equal to, this is a sign that shows that the number on this side is bigger because the mouth is bigger than this side. Think of it as like a crescendo versus decrescendo. Okay, so now all we're going to do is we're going to go over two questions. So the first example is 3 times x plus 6 minus 2 times x, plus 2. It's greater than or equal to. That's why they have the line at the bottom. 10. So as you can see, there's a bunch of distribution to do here, but no worries. It's simple. It's not too complicated. Just what I think you should do is split this into 2 parts. So that's part 2, and this is part 1. So you're just going to distribute the 3 there. 3x plus 3 times 6 is 18. And then we have another part. Negative 2 times x is negative 2x. And then negative 2 times positive 2. So a negative and a positive equal a negative. So 2 times 2 is 4, and you just add a negative. Negative 4. Greater than or equal to 10. So as you can tell, you can just leave it like that because these do have signs. It just looks a little separated, but I would have written them a little more together. So all you do now is combine like terms, which are terms that are similar, so the x's. So 3x minus 2x is just 1x, or x. And then 18 minus 4. Because this minus goes to the 4. This is part of the 4. This minus is part of the 2x. This plus is part of the 18. 3x is not negative. So it's 18 minus 4, which is 14. Is greater than or equal to 10. So all we do now, the x, as you can tell, has something beside it, but we can't have that. So we need to remove this 14 by taking it out, subtracting it. So x is greater than or equal to negative 4 because this is a greater number. So you go like pretend this is 10, negative 10. So from here, you already completed removing removing 10. So you need to remove 4 more. So you go to this negative number right here. Okay, so this is the answer to the first question. Now we're going to try just another one. Oops. And this question is a little bit complicated just because it has a fraction. But don't worry, it's not too bad. 6x plus 3 is less than or equal to 2x minus 7. So the only thing we have to do in this is, first we're just going to focus, don't focus about this portion, we're just going to focus right here. So what is 5/3 over 3 times 6? So what you can do, you can simplify this. So either you could just multiply it and make it 30 over 3, divide that and make that 10, or you could do it much easier where you could take the 5 over 3. And 6 and 3 are related in some way. So we're going to figure out how. We cross out the 3, that becomes a 1. You divide 6 by 3. What does it give you? 2. So now all you do, 5 times 2, 10. Same way, but I just feel like the second way is a little more simpler. So that's the first part. We have there's an x beside the 6, so it's 10x. And then right here, let me just write that x here so you know where it's from. Okay, and here. And now we're doing the same thing, but 5/3 times a positive 3. So again, you could do 15, 5 times 3, 15, divided by 3. Also, the reason why I'm multiplying to the top is because imagine this 3 as 3 over 1. So it'd be 3 times 1 and 5 times 3, like that. So all we have to do now is we just have to multiply. Instead of multiplying like this way, I would just cross these out, see what's similar, make them 1s. 5 times 1 is 5. So the end product of the left side is 10x plus 5. It's less than or equal to 2x minus 7. So all we want to do now is we want to bring the x's to one side and keep the numbers on the other side. So 10, oops, so sorry. I don't know what happened. 10x plus 5 is less than or equal to 2x minus 7. So bring the x's on one side. I like to keep my x's positive, so it looks a little less complicated. So 8x right here. There's a 5 here, which we do need to remove. Remember to keep this negative 7, not positive. Subtract a 5, so it won't be 2 because a negative number minus another number, or like a negative number, this is technically saying plus negative 5. So negative 7 plus negative 5 is negative 12. Now you just need the x alone. So x is less than or equal to negative 12 over 8, or negative 3 over 2. Simplified it by dividing both sides by 4. Okay, so we are done with the review portion of it. That took some time, but now I'm going to get into the graphing relationships chapter. So it's not so complicated. All we're talking about are discrete graphs versus continuous graphs. So for example, I'm going to draw two graphs right here. They're a little not straight, but that's okay. Pretend there's some numbers like 1, 2, 3, 4, 1, 2, 3. Okay, as you can tell, this is just x. This is y equals x graph. But the difference is, these are just points. They are not connected together, so that makes it discrete. Not connected together. On this, on the other hand, 1, 2, 3, let's make it like that. This is a continuous because it is a line. All the points are connected in this graph. There's like points probably all over the place here, and all of the points are connected on the graph, so that is why it's continuous. So keep that in mind as we go on to the question portion of this part of the chapter. So the first question is asking, it has a huge graph over here. Okay. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so this is a graph where it shows the number of people in an X amount of times, or X amount of time, sorry. So all we're doing is we're trying to identify what these different numbers mean. So the first part of this is compare segments 1 and 2. So this is segment 1, segment 2. So 2 is showing that, okay, so if a line is a little more horizontal, it is slow. Or even like if it's like this, it's slow. But if a line is like that, it's so fast. It's fast. It's showing that number 1 had much more people at a very low time, whereas 2 had less people in X minute of time. But 1 had more people in X-min. You don't need that. Okay. So all it's showing you is when a line is a little more vertical, it is showing how fast it is. It's humongously fast. It's so fast. So if we were talking about that in terms of car speed or something, if it was this, you could imagine maybe 20 miles per hour, whereas this is a complete like 100 miles per hour. So now we're going to talk about the number 5. So what 5 is doing is, as you can tell, it is horizontal. It's basically straight. So that means, so it's 5 and 7, sorry. They're asking about 5 and 7 because, as you can tell, horizontal on both sides. I just messed up the graph. That's okay. What I meant to say is, when it's horizontal, it means it has a complete stop, and it's just staying linear for a long time. So if you graph y is equal to 2, y will always be equal to 2 for any x value, which is what this is saying. So for when the time was passing, the same amount of people were there for this period of time. Same for this period of time. So it's saying no growth in people numbers, like people values. So, and then it's asking what is 8 doing? So as you can tell, 8 is a huge drop, not climbing up like that, but climbing super down like that, which shows that it dropped at a fast rate. So pretend this was just 10 minutes. So minute 1, maybe 2.5, 4, 5 to 7 or 8. So it's showing that within literally 30 seconds, the 8 dropped about half of its percentage of people. So that is what we're going to say. Many people left. And it says in this scenario, it's in a hockey game, so many people left the arena, which is, I think, the purpose of it. So now what we're going to do is we're going to identify discrete versus continuous graphs. Hopefully y'all understood it. You also pause the video when I was writing all of that down if you needed to. Take time to consider it to yourself. Okay, so what we're going to do now is I'm going to draw a couple graphs, and we're going to identify discrete versus continuous. Pretend that's curved. Okay, these need arrows. Okay, so as you can tell, this is discrete because there are just a bunch of dots and they are not connected, so the data is not connected in any shape or form. But this is not, it's continuous, but it's literally just constant. So pretend it was like cups that people are drinking from. And so every time the line increased a little, it was going like more people were taking more cups. So pretend this is like 10 cups. The bottom obviously is 0 because the origin's here. So in this situation, people were taking cups, but it wasn't continuous. In this situation, from the beginning itself, there were already 5 cups gone, and no one took anything after. In this, it starts off as, these are also continuous, but let me explain this because it's curved. So it starts off where no one takes any cups. By the end, everyone took it. It rose at a very drastically fast-paced, but in the beginning, it was like sort of horizontal. And in this, it was just constant, linear. Every minute, someone would take a cup. So that is all I have for y'all today.